vectors have magnitude and direction. Is it clear what that means, or would you like some more explanation on that?
I think I get it.
Okay, magnitude, and then they have direction. Okay, so I'm gonna create a vector u. U is going to be -4, -3, and then v is going to be uh, 2 times 2 times u. So it'll be uh, -8 comma -6. Okay. Now a unit vector goes in the same direction. It's in the same direction as the original vector. So all vectors have a unit vector. I guess that could be like a true false. All vectors have unit vector. All vectors are they're pointing in some direction. They have some length and so on. To find the unit vector, and sometimes the u is used for unit vector, which doesn't work well with this, but we'll just say the unit vector. It's the vector itself over the magnitude of the vector. Okay, so what do I mean by magnitude of the vector? Well, you have to use, it's basically like finding the hypotenuse of a triangle. It's -4 squared plus -3 squared square rooted.
Okay.
Okay, so that's -4 comma -3 over, and that ends up being 5. So oftentimes it's simplified to this -4/5, -3/5, like that.
Okay.
Okay, now we're going to do this for this other one, v. V is -8, -6. So the unit vector in the direction of v is -8, -6 over -8 squared plus -6 squared square rooted. That ends up being -8 comma -6 over 10. So that ends up being -4/5, -3/5, like that. And you should notice that these are exactly the same. So if two vectors point in the same direction, they have the same unit vector.
Okay.
But that's not what this question is asking. And that's where we have to make sure you first understand what a unit vector is. It's the vector of unit length 1 in the same direction. So like if this is u, the unit vector is this little part there. If this is v, the unit vector is that little part there. That's unit 1, length 1.
Okay.
All right. Now, to have different unit vectors, the only way to do that is if they go in a different direction. So to have a different unit vector, they have to go in a different direction, and there's only one option. That's a -1, or -1, or like a -2 or -3 or so on. But it has to go in a different direction for it to be a different unit vector. So because it's a scalar multiple. So let's say like we just said here, u is, and we won't do all the calculations again, but let's say u is 3 comma 4. If v is -3 -4, if we just draw this right here, here is 3 4, and then here's a -3 -4. See how they go? And this is u and this is v. They go in opposite directions. The unit vector in the direction of u is that one, and the direction of v is the one they'll go in the other way.
Okay.
All right, so let's look at the last question on this review. What is the possible range of values for the magnitude of a unit vector? So we already wrote the formula, but I'll just be a little bit clearer about it. Let's say you have a vector AB. The magnitude of this is a squared plus b squared. This has to be greater than 0. It can never be 0. But we also talked about earlier, a vector has two things. It has magnitude and direction. Well, to have magnitude, it has to be greater than 0. So the magnitude of a vector, it has to be at least 0, but it can go up as much as it wants, because it can be this length, or it could be, forever
Okay.
length. Okay, we can move on to 6.2 now. There'll be more stuff here to talk about, unless you have more questions about.
That makes sense.
Okay, So next section is like about different things you can do with graphically on vectors. So I'm going to do B first, then we'll go back to A. So the most common thing you would ever do is you would add U plus V. You would add U plus V, and this question is saying like, well, how do you get this dotted line? Like, how do you get this dotted line from these questions? And it can be a little bit unclear, but let's let's pretend like we're starting here, and U is this down to the right thing like that, and then I grab V and I go back and to the left. What could I have done instead of going down to the right and then back, left, up? Couldn't I have just gone this dotted length?
Mm-hmm.
So U plus V is when you add the previous one to wherever the last one ended. So U ends here. It starts here. It starts, stops, but V starts there, ends there, and then it's like, well, how could I have just gotten there instead? So it's like, instead of saying, oh, I went, 4 right and 2 down, and then left 1 and up 3, you could just go this trajectory to get there.
Right.
Or think about, oh, I get to school, I went this way and this way. That's possible.
Okay.
And now there's other things you can do, and there's really only 4 that are going to come into play in your class here, most likely. So U plus V, U minus V, minus U plus V, minus U minus V. So if you have a vector, and I'm just going to draw them here for clarity before I go into the example. Let's say this is U out to the right. What is minus U? What would minus U be?
That
Going the other
opposite.
way. And let's say V is up 3, then minus V would be down 3. So if it just means you flip the direction of them. So let's look at A and see if we can come up with the answer to how to do these clearly, how to, like, what makes sense. So this one's more confusing. That's why I don't know why it's first, but it is. So let's say you went V to here. What is minus U? What is V minus U? Because I think that was, well, we didn't have that one, but what does minus U mean? Well, V means you started here, and we'll just grab that. So V means I'm going down and to the right. That's V. Minus U, well, U normally goes to the right, up and to the right. So minus U is going to go down and to the right. That's minus U. See how U went to the right, but now the arrow changes the direction of it. So
Yeah.
now our resultant is here, which is going down. Is that the direction this goes?
No.
No, it goes up. So this isn't right, but it's sort of right. So now let's try the other one, U minus V. So all I did was switch the signs. So U, I'm going to start, you just pick a place. Actually, I got to start a little lower. Okay, so U is like, okay, I'm going to go there. That's U. V goes down to the right. So where's minus V?
Up and to the left.
Yes. So there's minus V, and then does this kind of match that?
Yeah, that does.
Yes. So there's our answer. It's U minus V.
Okay.
Now I should warn you, like there could be possibilities, like it could be like U minus 2V or 2U minus V or 2U plus V. Like you can add numbers to this, but in strictly in terms of just 2 vectors, there's only 4 possibilities. These are the 4 possibilities.
Okay.
And if this isn't clear, I can give you a short example for that, or we can move on to the next question.
That makes sense.
All right, so moving on to question 2. It says to find, and this is one of those things, like it's kind of like composite functions and then multiplication. The instructions say find U dot V, and that literally means the dot product. That means dot product. And you should always ask if it's unclear with your instructor, like, do you mean dot product? And hopefully they say yes or no, and they don't say you should know that. But um, this is dot product here. Okay. Now, dot product means that and the more traditional examples I give you, I tell you that U is 1 comma negative 3, and V is 2 comma negative 4. and u dot v is 1 times 2, 1 times 2 plus -3 times -4. Problem is here is we don't have any of that. We actually don't have any of these vectors. We just know how long they are, and we know the angle between them. So you probably had a formula given to you for angle between at some point. The angle between two vectors, the cosine of theta, equals u dot v over magnitude u times magnitude v. Does that look familiar? And
Oh, yeah, absolutely.
you asked me, this is like one of those things, I used to do this all the time for students. I kind of box in things that you need to know. So what do you need to know here? You need to know theta, and you'd really like to know the vectors. But if you know the magnitude of u and the magnitude of v, you're good. Because what they're essentially asking you to solve for is this numerator. That's what 2 is asking you to solve for, is the numerator. So you can see the numerator, u dot v, is cosine theta times the magnitude of u times the magnitude of v.
Right.
In your problem, theta is pi over 3. The magnitude
Yeah.
of u in your problem is 3. That's the length of it. The magnitude of v is 5. So this is cosine pi over 3. So you got to go back and know your unit circle. Times 3 times 5.
Okay.
So do you recall that? Do you recall the cosine pi over 3? So there's pi over 3. So it's 1/2 comma square root 3 over 2.
Right.
Do you remember which one's cosine?
It's 1/2.
Yes. So this becomes 15 halves.
Okay.
So what's interesting is in part B, they don't give you the angle, but you do it exactly the same way. Do you know the angle between those two if they're on the same line, if they're
180.
180 degrees? So you actually know theta here is 180 degrees. So if you don't mind, will you actually calculate the u dot v? I'm asking you to do this calculation down here for this problem.
Okay. -15.
It is -15. I'm glad you put that in there. That's exactly what's needed. So now let's say I tell you that I give you two vectors, and I tell you that this is 3 and this is 5 again, and I don't know the angle, but I tell you the dot product is equal to 0, and I want you to find the angle. So this is a working backwards question. This is giving you different pieces of information, and I want you to find the angle this time. I have given you enough information to do this, but I can also work through it if it's not clear. But give it a try, please. See if you can come up with that angle. It ends up being a conceptual question.
So we have to figure out like when the cosine of theta equals 0.
Exactly. And there's two places
Okay.
on your unit circle.
0 to, what was it? It's pi over 2?
Yes, pi over 2 or 3 pi over 2. Okay. Now tell me, just like why would it never be this? And I'll try to explain that. If the angle between these is 90 degrees here, would you ever tell someone it's 270 degrees between them?
No.
No. So that's why it's only this one is that.
Okay, that makes sense.
So now what I was referring to is that it's possible your instructor could say something like, how do you know it's 90 degrees? How do you know the angle is 90 degrees between them? And you know this because the dot product is 0. The dot product is 0 means that it's a 90-degree angle between them.
Okay.
If the dot product is negative, then they lie on a straight line. If the dot product But that's not always true either. It just means that there's more of it in the same direction as the other. And that's where we get into question 3, which really is not a difficult question conceptually, because you actually know how to do this for other angles. So I'll diagram that, and then I'll go through question 3 real quick. So let's just say I give you a vector, and I've already done this a few times. I said u is 3, 4. U is 3, 4. Okay, that's u, that's 3, that's 4. And I say, what is the projection of u onto the x-axis? You would say that that is 3. The projection of u onto the x-axis is 3. It's literally saying how much of u goes in the x direction.
Okay.
And so how much of u goes in the y direction?
4.
4. Okay. Now in this problem over here, you want to consider the thing that you're projecting onto, the onto part, that's what you treat as your x-axis. So it's really saying how much of A goes along the x-axis here, or the b-axis. So there's a right triangle here, just like there's a right triangle here, and there's this amount that I'm highlighting. That's with the cursor. That's how much is projected onto B.
Okay.
So it's just this amount here, like that.
Okay.
All right, can move on to next section.
Yeah.
Okay. I just need to fire off one message here, and then we'll be able to jump into that. All right, okay, so parametric equations, it's kind of a one-off. You don't see this again until other classes. It's actually most applicable to physics, but they never teach it this way. But it truly is how projectile motion is taught is this way. So the way you work through a problem here, when it's just essentially just asking you to graph or show a picture of what's happening, is you set t equal to some number. Now, normally they say, oh, t must be greater than or equal to 0, but you don't know in this problem what t is. They just don't address that. The problem though here is t is inside the cosine, so that means we're kind of limited to unit circle values, and nice ones. Meaning, like, you have to take the cosine of it, so it better be a nice value. So values are like 0, pi over 2, pi, 3 pi over 2, and so on, like that. So you want to kind of think of that ahead of time. If it was sine, it would be the same thing. I know, like, the cosine of 60 degrees is nice, but you also have to put that number over here. So you don't want to use degrees. You want to use the radians here. So we're going to get a graph here. We're going to get some sort of graph, but we're going to do it by saying, okay, what's t? What's x, and then what's y. So we're going to get these ordered pairs here. So let's just let t equal 0. Okay, we'll just do it for part A. X is equal to t plus cosine of t. So this is 0 plus cosine of 0. What's the cosine of 0?
Pi over 2.
You're thinking of something else. Cosine 0 means 0 degrees.
Oh, yeah.
So you're right here. So it's just the x value there. So it's just 0 plus 1. So it's just 1. Y is always equal to 4, so y is equal to 4. So we have our first ordered pair here, and you almost need like a condensed form of this table, which I'll try and do over here. T, x, y. So our first ordered pair is 1, 4. Then we'll plug in this pi over 2. So x is equal to pi over 2 plus cosine pi over 2. Okay, so cosine pi over 2 is 0. So this part is 0, so it's just pi over 2. So pi over 2, this part is pi over 2. And then y is always 4. That's what that means. So we're just using this top equation. Then we'll go to pi. So we have x equals pi plus cosine of pi. Cosine of pi is -1. That's pi. So this is pi minus 1 at pi, and that's still 4. And we'll do one more here. 3 pi over 2. So that's x equals 3 pi over 2 plus cosine 3 pi over 2. Cosine 3 pi over 2 is 0, so this is just 3 pi over 2. So this is 3 pi over 2. It's still 4, and so on. So again, you might be thinking, well, what do I do with all this? Well, now we're going to graph this. So you graph the xy stuff, though, first. So the xy stuff, when x is 1, y is 4. That's not too bad. Where is pi over 2 over 4? Well, it's bigger. It's bigger than 1. It's 1.57. So it's somewhere over here. Pi minus 1 is a little bit bigger than 2. So that's about there, and then so on. So when you start connecting these points, now there's not a lot there, but they actually all go to the right. And then you just specify that there's this. Now, it actually goes infinitely in both directions because we didn't specify where t started.
Right.
Okay, is there any questions on that? Because that leads into the next part.
I think I get it.
This isn't the best example. Like usually they're nice ones that like have a nice curve or whatever, but this one doesn't have that, unfortunately. Like
Yeah, that makes
sometimes there's like these nice spiral things, but this one doesn't have it. So part B is doing the same thing. Part B is just a slightly different thing here. So all of the x values are going to remain. So let me just grab this from the table here. I'm just going to copy this table down, and then we'll refine a y value. So the y value in part B, it says that y equals negative t. So the difference is that it's no longer just 4. This actually changes. Okay.
okay.
All right. So the y value here is 0 because that's negative 0, then negative pi over 2, negative pi, negative 3 pi over 2. And you'll see it's the graph is quite a bit different because before the y value, that was 2, that's not going to work. The y value was up pretty high, 1, 0. It was up there. Now it's here.
Right.
Okay. Pi over 2 minus pi over 2, so it's down here-ish. Then minus pi is down here. So I don't know exactly what it's doing. It's not quite a straight line, but it's doing something like that. And then we really need to go in the other direction, but it looks like it's doing something like this. All right. So that's the difference between A and B. All right. So let's let me talk briefly about. Well, we have plenty of time here because we're on the third section. Okay, let's look at 3A. Consider the parametric equation, and it says find the endpoints of the curve. So this is what I meant by like it has a starting point, a start, and a stop. Okay. So the starting point is when t equals 2. It's not 0, it's not pi, it's just where t equals 2. So x is equal to f of t, which is equal to f of 2. We don't know what that is, but that's the starting point. Y is equal to g of t, which is equal to g of 2 because we know that t is 2. So the starting point, the place that this thing starts, when t equals 2, you're just taking this value, and maybe in your exam it'll be t and t squared. I don't know what it'll be, but your xy is f of 2 comma g of 2, something like that. And where it stops is when t equals 9.
Okay.
All right, now the t equals 9, it's kind of the same deal. It's just f of 9 comma g of 9. So those are your starting points. And we don't know, like this could be f of 2 and or f of 2 g of 2, f of 9 g of 9. We have no idea what happens in between here. But that's all we know. What's the starting and the stopping point.
Okay.
Okay. I'm gonna skip over B and I'm gonna go to C because C really C, D, E, and F, they're all kind, or C, D, and E, they're all somewhat related for this. So these are just transformations to think about.
Okay.
And there's actually there's shifts. There's also, we'll just call B a vertical, and we'll call A a horizontal. So let's just say x is equal to f of t and y is equal to g of t. So a horizontal shift occurs inside here. So let's say we want a horizontal shift of a units. That would look something like this: f of t minus a, and that's a units right. If you have not, if you're not remembering this, or this is unclear, go back and think of like x squared. If we go y equals x minus 2 squared, maybe 3, that means 3 right. Is that something that looks familiar?
Yeah.
All right. So then same thing over here, though. Y would be g of t minus a as well. So that's part A for a horizontal shift. For a vertical shift, it goes outside the function f of t, y equals g of t. So it's x equals a plus f of t. That's a units up. And y would be like a plus g of t. That's the same thing, a units up. Okay. So what would it look like now? We'll get to see here, which is a vertical stretch by a factor of 2. Do you know where that 2 goes?
In front of the f of t.
Yes. And same thing here, y equals 2 g of t. Same thing there.
Okay.
Okay. Now that's if it affects both of these. I really don't know what this is referring to, if it's just one or the. Um, so I would suggest I've sort of just covered this. I can't really tell you what the instructor might cover on here. I would think it'd be some sort of a question like number 1, where you had to actually you actually have to graph something or show something for that.
Yeah, probably.
Okay.
She didn't cover this for very long, so I think this is enough.
All right. So I'm gonna move to question 4, and this one I think is the most, maybe the thing with polar coordinates is that you're used to being told to get to if I want you to go from point A to point B, you're used to being told go left, right, and then go up and down. And this is X and this is Y. Okay, like you're used to being told go, -2, go left 2, and don't go up or down. Okay,
Right.
but with polar, it's different. With polar, you end up doing the following: you end up rotation, followed by, I call it a step. It's like a jump or direction. And if you consider your whole world, like all you know is I'm pointing to the right, like that's your whole world. That happens to be theta equals 0. If I want you to point straight up, there are 2 ways you can get there. You can rotate counterclockwise 90 degrees, or you can rotate clockwise 270 degrees. And do you get to the same place?
Yes.
You do. So the issue here is like there's actually many ways to get to the same place, whereas when you're going what when you're going up, down, left, right, you have only sort of one way to get there. So this one is saying that you are at this position -2, 0. You're over here at -2, 0. It's like, how can you get there on? It's no longer the unit circle. The unit circle is here. This circle is a like that.
Okay.
So this is no longer the circle. It's really the radius of two circle. So we have to
Okay.
get to this point here, and your whole world is like you're pointing there. You're a person, and you are currently you can only do two things. You can spin, but once you're done spinning, you can either step forward or backwards.
Yeah.
Okay, so you're pointing to the right here. That's your visual. To get to this point right here, I can spin you counterclockwise 180 degrees. So when I spin you, you're still here at the origin, but you're facing left.
So a step forward will mean something different than it did before.
Yes, your two forward gets you there.
Okay. So you always have to do the rotation before you do the like step.
That's the way that's the way I prefer to look at it. It can be a few different things, but yes. Now
Okay.
you can also rotate clockwise. Okay.
Right.
Now it is 180 degrees, but in terms of like what we think of it, it's minus 180 degrees when you're going that way. So you're here at the origin and you spin. Now you're facing left. You still take a step forward, 2 steps forward to get there.
Okay.
Now there's other possibilities here. Here's another possibility. You're facing forward. You're facing forward, and you can take 2 steps back.
Okay.
You can also rotate 360 degrees counterclockwise or clockwise. We'll just say counterclockwise. So that means you're facing to the right. You spin all the way around, so you're still facing to the right, and then you can take 2 steps back.
Okay.
Now, why am I going through this? It's because your problem has it says the angle can be anything in this window.
Okay.
Now you can also spin negative 360 degrees, and then you take 2 steps back.
Right.
So this one's a little bit of an oddity because usually they don't include both of these endpoints, but there's normally like 4 answers every time you want to get to a place. There's the angles with the same forward steps, and then negative of the steps with different angles. Like all the angles are going to be different. You're going to have 4 different angles, but you're going to have either positive steps or negative steps.
Okay. What's the difference between like parametric and polar?
Very different. So parametric is you get x as a function of t and y as a function of t. So basically, if you think of a box, like your input is time, and you get out x and y. And polar is a radius or a direction and an angle and a step. They can be used to describe the same things, but they're so this is a new part of math for you where you have what are called changes of space to these new coordinate systems, and they work better in certain problems, different coordinate systems, rather than being stuck on x, y.
Okay, that makes sense.
But I don't think you'll be asked to compare them, but maybe that would. The main difference though is parametric equations are in terms of time. That means they have direction. Like you could have a circle and you could be going that way in parametric. In polar, you just have a circle. You don't know, you don't care which way you're going. Parametric equations though could be used to describe, things like that go along like this. They have a direction.
Right.
But polar would just be generally reserved for things like circles or some lines, whereas parametrics tend to have more curves to them.
Okay, that makes sense.
All right. Got some
Do you think we
time
could
left.
like do the thing where you tell me what I should put on the review sheet?
Sure. So first thing for vectors is you need to know that vectors have magnitude and direction, and you need to be able to give an example of that. Like, what is a vector? What is a scalar? So this is vector versus scalar. So your car is speedometer is a scalar. It doesn't care whether you're going north or south. 40 miles per hour is 40 miles per hour. Vector is it's got what we just talked about, magnitude and direction. Like it matters which way you're pointing.
Mm-hmm.
If you think of do you play sports? Any sports in particular? It's
No,
okay if
not
you
really.
don't. Okay. So the think of yourself doing something where if you don't have the right direction, it doesn't go where you want. So
Okay.
you have to have an aim, so to speak.
Okay.
But it's a very common question. What's the difference between a vector and a scalar? So you have to know that. Um, the unit vector always has length 1. Magnitude of the unit vector is always equal to 1. If a vector has a and b as components, the magnitude of it is let's call this v. The magnitude of v equals a squared plus b squared square rooted. And v, the magnitude of v is always greater than 0. But the unit vector is v over the magnitude of v. And we did a few problems like that earlier where we divided by a number here. And then we talked about the dot product. So the dot product, you have to have two vectors, a and b, and then we'll say v equals c and d. The dot product u dot v is equal to a times b plus c times d. And this equals a number. This is always a number.
Okay.
So here's maybe this could be some of those questions your instructor asks. They could say, what is v times u dot v? And it could be really simple. Is it a vector or is it a scalar? And a scalar just means it's a number. Well, the dot product is a number. We just said that. If you take a number and multiply it by a vector, what do you get?
The vector.
A vector. Now it could be something like, so this is a vector. Could be, what is u dot v times v dot u?
That's a scalar.
It's a scalar. It's a number. Okay. There's a bunch of these that you could get. I'm not sure what your instructor would ask, but that's there. So then you can find the angle between two vectors. Okay. So the angle between cosine of theta, this is the formula, is u dot v over magnitude of u dot magnitude of v. So if u dot v equals 0, if the dot product is 0, we know that the theta is 90 degrees. That means they're right angles.
Okay.
The
Or that has a special name, right? That's like orthogonal or something like that.
yes, yeah, right, orthogonal, normal, they're all the same. Okay. So then I mentioned all these things that you could do with vectors. You can add, you can combine. You can combine vectors. So u plus v, u minus v, minus u plus v, minus u minus v. These are all you can add and subtract vectors graphically. So you somehow want to get that consolidated. Like, what is, what, like, is it okay, forwards, backwards, adding, subtracting, and so on for that.
Okay.
Okay, so now parametric equations. So we talked a little about parametric equations, not much. So the idea is that you have x as a function of t and y as a function of t, and you have to always specify the direction.
Okay.
Okay, polar is a little bit different because we have a few more equations. We have x squared plus y squared equals r squared. X equals r cosine theta, y equals r sine theta. You can you can move between these, I guess is what I'm trying to say here, with polar equations. We talked about you have r and a theta for your so the ordered pairs. I didn't make this clear. The ordered pairs actually come r comma theta. I was writing them theta comma r, but they should be written this way.
Okay.
And it doesn't change anything that we said, but you generally want to think of things in terms of clockwise and counterclockwise, and then steps to move it. So to get to a place on the unit circle, there's generally 4 ways to get there. So there's just generally 4 ways to get there. So it would be r comma negative angle. I'm sorry, r comma angle. That's probably the easiest one. R comma 2 pi comma minus. See, I think this is unclear because then we start getting into these things. There's first 4 ways to get there, and maybe I should just leave it at that. There's maybe you want to draw some arrows like it's like there's 1, there's 2, and then you draw the line over in this way, and there's 1, and then there's another one to get there.
Okay.
And that's how and then you're either stepping forward or backwards to get to it. Looks like you still need, go ahead. Sorry.
Is that something about like positive r, positive theta,
Yes.
negative,
Yes.
and then any combo of that?
Yes. Yeah. The ones that there's generally like 4, so you just want to make, you don't want to miss. But the R is, it's I guess that's what you said here. The negative theta could be unclear, like what that means, because there's actually 2 possible negatives that it could be, depending on how you get there.
Okay.
So these equations on the right are how you would go. Like we did a problem where I gave you the x, y, and you had to find r. You could be given the angle and the r to find x and y, and that's kind of what 3 is asking you to do in 6.4. You actually sketch the position, but you generally convert them to x-y pairs first.
Okay.
If that's not clear, we have enough time to go through that. If you want.
Can we do a projection problem?
We just did with actual numbers.
Yeah.
Okay, I'll have to look one up.
Also, I remember seeing like a equation for projection.
Yes.
Okay.
Yeah, I gotta find one that's. All right, so the it's written this way: U onto V. I'm sorry, V onto U. So it's you gotta be careful because these are written in really weird ways in different textbooks. V onto. Sorry. Projection of U onto V. U onto V is. There's actually 2 things, but it's the projection. They write it this way: U dot V over magnitude of V squared times V. So I have to give you U and V, and that's generally how it's given. U is equal to I don't know. We'll go -1, -2, and we'll say that V is equal to 3, 4.
Okay.
So you have to find, like, and what I like to do is actually like to find all the little pieces. So U dot V is -1 times 3 plus -2 times 4. That's -11.
Okay.
Magnitude of V squared, it's 3 squared plus 4 squared square rooted, but then you square it.
Okay.
So it undoes that. So it ends up just being 3 squared plus 4 squared, which is 25. So this produces, if we go down to this equation, it's U dot V is -11 over 25 times V. V is 3 comma 4. And then you're just multiplying this number times 3 and then times 4. So it's -33 over 25 comma -44 over 25.
Okay, that's great. Thank you.
There's also a formula for the component of V, which is just the part in front, this number in front, but generally this is what the dash. Now you have to be really careful. Like sometimes you can get problems, and let me I would assume your instructor would do something awful like this that makes it really hard for understanding. Let me snip this in here. This is
She does
probably,
a lot of the where it's like, oh, you're pushing this object up a hill.
I was going to say, sometimes it's like B onto A. Like you might
Oh,
see that, and you're like, oh, what do I do? So you just got to map the letters. So this is because the dot product doesn't matter. So it's B dot A, okay? But the number on bottom is the one that you're onto. So it's magnitude of A squared. And then this one matches the one on the bottom. So times A.
okay.
And just gotta be really careful that you get those because she could just as well ask for A onto B.
Right.
And then you'd have to, figure that one out down here. And it does change just a few things, but make sure you have that mapping down.
Okay.
All right. Is there anything else we can cover?
That's good. I think to prepare, I'm just gonna go through all the problems on the sheet that are remaining, do a couple from the book, and make my sheet.
Okay. Well, thank you again for scheduling. It sounds like a good plan. I'll try and send this out right away. So you got these notes, screen recording here for you. I just hadn't got to the other one, but I'll do it here in the next hour.
Okay, thank you so much.
You're welcome. Bye now.
Bye.